On notes 2-3, we're going to be using laws of logs to solve our equations. Okay, so on 2-2, we did the same thing, except yesterday we had some terms that were not logs. Okay, so we only had some that were logs. Today we're going to have all of the terms will be logs. Okay, all right. So if each term of an equation has a log expression, you're going to condense, which means get it into one. Condense each side to one log expression and then use your property that we're going to talk about to solve. So if you have a log that equals a log and the bases are the same, then that means that m has to equal n because those are equal. Okay, so if that's the case, once you condense both sides to one log, then all you're going to do is set m equal to n and solve for x. So if we look at number 1, notice we have on the left side only one log term. On the right side we only have one log term because we have parentheses. Okay? Since we have one log that equals another log and the bases are the same, we're just going to set 3x plus 5 equal to 8x minus 12. Okay? So we're just basically dropping the logs off. Okay? So we're going to solve for x. Now we have a linear equation. So I'm going to subtract 3x. We have 5 equals 5x minus 12. And then we'll add 12. So that's 17 equals 5x. And then divide both sides by 5. And leave it in fraction form. So our solution would be x equals 17 over 5. Now, how you can check these is plug it back in for x, and they should be equal. The left side should equal the right side, because those are the same logs. Okay? All right, 2. Notice we have one log on the left side, one log on the right side. But notice on the left side that we have a coefficient. We talked about the law a couple of days ago. When you have a coefficient, to condense it, you're going to make it an exponent. So I'm going to go ahead and do that. Now notice the logs are equal, the bases are the same, which means x cubed will have to equal 27, because we know those logs are equal. From here, we're solving for x. So the opposite of cubing something would be taking the cube root. So that's what we'll do, is take the cube root of both sides. So the cube root of x cubed is just x. Cube root of 27 equals 3. So solution would be x equals 3. You can plug that back in. It should be equal. Okay, because 3 cubed equals 27. So you can plug it back into that original equation there. Alright, looking at number 3. Look at the left side. There's only one log. That's how we want it. Look at the right side. We have 2 logs, which means we want to condense it into 1. So I need to get rid of this coefficient and make it an exponent. And then notice we're adding these 2 logs. So to condense into 1, you're going to multiply them. So I have log base 2 of x, because I'm not changing the left side. The right side, I'm going to have log base 2. I'm having to multiply those together. So 3 squared times 5. So 3 squared would be 9. And then I have to times it by 5, so that would equal 45. Now notice these logs are equal, the bases are the same. We're just setting x equal to 45, and we have our answer. So you're condensing the left side into one log, condensing the right side into one log, and then just setting your m equal to n, because those are equal. So x would equal 45. All right, looking at 4. Notice we have all log terms. The left side we have 2 logs, the right side we have 1. We want that left side to condense into 1. So notice the bases are the same, so we have log base 8 Notice we're subtracting, so to condense into 1, we're going to divide. So I'm taking the first one, which is 48, that will be on top, over the second one, which is x. Okay, since those logs are equal, we are going to set our m equal to n, so 48 over x equals 4. You can either put 4 over 1 and cross multiply, or get rid of the x. We're dividing by x, so I would multiply it on both sides. So we would be left with 48 equals 4x, and then divide by 4. So x would equal 12. And you can plug it back in to check it. I would say plug it back into this part here, because 48 divided by 12, you're going to get 4 on that other side. But you have to know your laws of logs in order to get to that second step there. All right, number 5. Look at the left side. They're all logs, but there's 3 of them. The right side, it's a log, but there's only 1. We want 1. So the right side we don't need to do anything with right now. We want to condense the left side. So I have log base 7. Notice that I'm adding these two together. So to condense, I would multiply them. So x times x. And then we're subtracting the log base 7 of 3, which means we would need to divide by 3. Whatever you're subtracting will go in the denominator. Just going to rewrite that right side. I'm going to multiply those x's, which would give me x squared. So now I can set my m equal to n. So just drop the logs. We have x squared over 3 equals 12. I want to get rid of the 3, so we're dividing. So opposite would be to multiply. Those 3's cancel. We're left with x squared equals 12 times 3 is 36. Now we already talked about getting rid of that cubed on the front. To get rid of a squared, we would take the square root of both sides. Square root of x squared is x. Square root of 36 is 6. Now remember we talked about what number could we plug back into square and get 36. That answer would be positive and negative 6, but remember we talked about on 2-1 that our m or n has to be positive. If we would go back and plug in a negative 6 here, that is going to be a negative, and we can't do that. Okay, so the only answer we'll put is that positive. So x equals 6. Okay, last one. So notice the left side we have 2 logs. The right side we have 2 logs. So the left side we're going to condense into 1. The right side we're going to condense into 1. So notice on the left side we're subtracting. So to condense we will divide. Log base 2. The first one is 2x minus 1 divided by the second one, which is x plus 5. Looking at the right side, we have coefficients. Before we can divide them, because we're subtracting, we'll need to get rid of those and make them exponents. So I'll have log base 2. We have 36 to the 1/2 power over 2 squared. Now notice both of those are numbers. We don't have any variables there, which means we need to evaluate that. So I'm just going to rewrite the left side. Then the right side, 36 to the 1/2 power. Remember, we've talked about this several different times. Anything raised to the 1/2 power means you're going to be taking the square root. The square root of 36 is 6, and 2 squared gives you 4. Okay, so now we can set our m equal to n. So 2x minus 1 over x plus 5. To make it a little easier for me, I noticed that 6 over 4, I can reduce that to 3 over 2. But if you didn't notice that, you would still get the same answer. Okay? All right, so notice I have two ratios that are equal. That's called a proportion. To solve a proportion, we're going to cross multiply. When you cross multiply, make sure that you multiply this 2 by 2x and that 1. So you should end up with 4x minus 2. And then same thing on the other part. Make sure you distribute that 3 to the x and 5. So that would equal 3x plus 15. So now we have a linear equation. We're going to move the x's to one side. So subtract 3x. So you end up with x minus 2 equals 15. So add 2. And you end up with x equals 17. So to check it, you can plug that back in and make sure they're equal. Okay, so this lesson was over equations that have all log terms. So when it's all log terms, you're trying to condense it into one log that equals another log. So that way you can get rid of those and solve for x. Okay.